The radar screens went black at 3:17 in the morning, and nobody knew why. Up and down the Atlantic coast, defense stations lost their eyes just as German U-boats prowled closer to American shores. Engineers scrambled, officers shouted orders, and in a cramped New Jersey repair depot, one civilian electrician stared at a tiny bead of water on a wire connector and realized he might be looking at the answer everyone else had missed. His supervisor would call his solution stupid, a waste of precious wartime resources. But Art Combs was about to prove that sometimes the simplest fix is the one that saves thousands of lives. Before we carry on, please hit the subscribe button to make my day and let me know where you are watching from in the comments. The summer of 1942 brought more than just heat to the eastern seaboard of the United States. It brought fear, the kind that settled into the bones of coastal communities and military installations alike. German submarines had been spotted within miles of major ports, and the only thing standing between enemy torpedoes and American merchant vessels was a network of radar stations that stretched from Maine to Florida. These stations represented the cutting edge of technology, massive installations with towers reaching into the sky, and equipment rooms filled with machines that could detect ships and aircraft dozens of miles away. But technology, as Arthur Combs had learned in his 32 years of working with electrical systems, was only as reliable as its weakest connection. Art wasn't supposed to be working on military equipment at all. Before the war, he had made a decent living repairing radios and electrical appliances in a small shop in Camden, New Jersey. He fixed toasters, rewired lamps, and occasionally got called out to troubleshoot problems at the local theater when their sound system acted up. It was honest work, the kind that kept food on the table for him and his wife Margaret, though it rarely provided much beyond that. When the war started and the government began recruiting civilian contractors to support the military effort, Art had signed up more out of patriotic duty than any expectation of adventure. He figured his skills with wiring and circuits might be useful somewhere, somehow. The radar repair depot in Fort Hancock turned out to be exactly the kind of somewhere the military needed him. Located on Sandy Hook, a narrow peninsula jutting into the Atlantic, the depot served as the central maintenance hub for all coastal defense radar installations in the region. Equipment that malfunctioned got shipped here, fixed, and sent back out. The work was repetitive, often tedious, but Art approached it with the same methodical care he had brought to every repair job in his civilian life. He believed that understanding why something broke was just as important as fixing it, a philosophy that his military supervisors sometimes found irritating when they wanted quick solutions rather than lengthy explanations. The problem started appearing in late June. Radar stations would report perfect functionality during the day, but as soon as the sun went down and the coastal humidity rolled in, thick and heavy, their systems would begin experiencing intermittent failures. Signals would drop out for seconds or minutes at a time, screens would flicker, and operators would lose track of contacts they had been monitoring. Given the critical nature of coastal surveillance, these failures represented more than just technical inconveniences. They were potentially fatal gaps in America's defensive shield. Initial investigations blamed the magnetrons, the sophisticated vacuum tubes that generated the radar's microwave pulses. Engineers pulled units apart, tested components, replaced tubes, and sent equipment back to the stations with confident assurances that the problems were solved. Then the next humid night would arrive, and the failures would return. Other theories followed in rapid succession. Maybe it was voltage irregularities in the power supply. Maybe it was interference from atmospheric conditions. Maybe it was sabotage, a possibility that sent security officers into fits of increased patrols and background checks. Art listened to all these theories while working at his bench in the depot's main repair bay. The building was a converted warehouse, its high ceiling doing little to disperse the summer heat that made every day feel like working inside an oven. Dozens of technicians and electricians occupied workstations throughout the space, each focused on their assigned tasks. The noise level rarely dropped below a constant hum of conversation, tool use, and the occasional burst of frustration when a particularly stubborn problem refused to yield to conventional solutions. He had been assigned to work on radar receivers, the sensitive equipment that picked up the returning radar echoes and converted them into usable information for operators. The receivers themselves were marvels of engineering, complex assemblies of tubes, capacitors, resistors, and miles of carefully routed wire. Each connection point represented a potential failure, and Art had developed a respect for the engineers who had designed systems that worked as reliably as they did. But respect for design didn't mean those designs were perfect, especially when confronted with conditions their creators might not have fully anticipated. The night that changed everything started like any other evening shift. Art had stayed late because a particularly troublesome receiver unit had been bothering him all day. The paperwork said it had been returned from a station on the Delaware coast with reports of intermittent signal loss during night operations. Previous technicians had already tested it twice and found nothing wrong. Their notes suggested the problem might be operator error or conditions specific to the installation site. But Art had a hunch, the kind of intuition that came from years of tracking down elusive electrical gremlins in equipment that supposedly worked fine. He had set up the receiver on his bench with all its external connections properly secured and its power supply running through a voltage regulator to eliminate any fluctuations. For 2 hours, he monitored its performance while manually adjusting various settings and observing the output on a test oscilloscope. Everything looked perfect. The unit performed exactly as specifications demanded, with signal strength well within acceptable parameters and no hint of the dropouts that had been reported. Then Art did something that probably violated several testing protocols. He walked to the depot's loading dock door, rolled it open, and let the humid night air pour into the building. Within minutes, the temperature at his workbench had dropped, but the humidity had soared. He could feel moisture settling on his skin, that uncomfortable dampness that made clothes stick and hair curl. He waited, watching his test equipment and the receiver, wondering if his hunch would prove correct or if he was wasting time on a wild theory. 20 minutes later, the receiver's output signal stuttered. It was brief, barely a quarter second, but unmistakable on the oscilloscope's display. Art leaned forward, his pulse quickening with the excitement of finally seeing the problem manifest itself. He waited. 3 minutes passed, then another dropout, this one lasting nearly a full second. The pattern continued, random intervals ranging from 2 to 5 minutes, each dropout lasting anywhere from a fraction of a second to several seconds. Most technicians would have immediately started checking the obvious culprits, the tubes, the power connections, the major circuit junctions. Art instead grabbed a flashlight and began inspecting the wiring harnesses, those bundles of cables that carried signals between different sections of the equipment. He moved slowly, methodically examining each junction box and connection point. The radar equipment used a variety of connector types, some quite sophisticated with locking mechanisms and weather seals. Others were simpler, just terminal blocks where individual wires attached with small screws. He found what he was looking for at a junction box near the receiver's antenna input section. Several of the terminal connections showed tiny beads of moisture clinging to the exposed metal where the wires attached. As he watched, a bead grew large enough to bridge between two adjacent terminals, creating a momentary short circuit before surface tension broke and the droplet fell away. There it was, the cause of signal dropouts that had stumped engineers and spawned theories about equipment failure and atmospheric interference. Just condensation, plain water vapor from humid air settling on exposed metal and creating unintended electrical paths. Art spent the next hour examining other receivers in the depot's inventory, particularly units that had been returned with similar complaints. He found the same evidence at multiple connection points: moisture accumulation on exposed terminals, wire ends, and any other bare metal surfaces within the equipment enclosures. The problem was worse on units that had been installed in coastal locations, where humidity combined with salt air created even more aggressive conditions. The equipment's designers had anticipated many challenges, but they apparently hadn't fully considered what sustained exposure to maritime humidity would do to standard electrical connections. The solution seemed obvious to Art, at least in principle. He needed to create a barrier that would prevent moisture from settling on the exposed metal connections. The barrier had to be waterproof, electrically insulating, and durable enough to withstand the vibrations and temperature changes the equipment experienced during normal operation. It also had to be something readily available, since wartime supply chains were already strained, and introducing new materials would require navigating layers of military procurement bureaucracy. He thought about the problem while cleaning up his workstation late that night. His mind drifted back to his days working in his civilian repair shop, remembering the various techniques he had used to protect electrical connections in different situations. Radio antennas installed on roofs needed protection from rain. Marine equipment needed protection from salt spray. Outdoor lighting fixtures needed protection from morning dew. Each application had its own traditional solutions, some more effective than others. The idea came to him while he was washing his hands in the depot's bathroom, scrubbing away the grime that accumulated during any day spent handling electrical equipment. He looked at the bar of soap sitting in its dish, and suddenly he was remembering his grandfather's workshop, where he had first learned about electricity and wiring. His grandfather had been a telephone lineman back when that meant climbing wooden poles and splicing copper wires by hand. One of the techniques the old man had taught him was wrapping outdoor splice connections with wax string to keep moisture out. The wax created a waterproof seal, while the string provided mechanical protection for the splice itself. Could something that simple work for sophisticated radar equipment? Art knew he had rolls of cotton string in the depot's supply room, standard material used for various purposes around the facility. Wax would be the challenge. He couldn't just grab a candle and start melting it over military equipment. But maybe he didn't need to. He remembered seeing tins of paste wax in the supply room, the kind used to protect metal surfaces from corrosion. That wax was designed to repel moisture, and it came in a form that could be applied to string easily enough. The next morning, Art arrived at the depot early, before his supervisor or most of the other technicians. He went to the supply room and found what he needed, a roll of medium-weight cotton string and a tin of paste wax. Back at his workbench, he cut several lengths of string and worked the paste wax into the fibers, coating each piece thoroughly. The result was string that felt slightly sticky and had a distinct chemical smell from the wax compounds, but it was definitely waterproof. He dipped one end in a cup of water and watched the liquid bead up and roll off the treated surface. He pulled out the receiver unit he had been testing the night before and began applying his solution. At each terminal connection, where he had observed moisture accumulation, he carefully wrapped the wax string around the junction, covering the exposed metal surfaces and wire ends. He worked the string tightly into place, ensuring good contact between the wax coating and the metal, while leaving enough slack that the wrapping wouldn't create mechanical stress on the connections. Each wrap took only a minute or two to complete, but Art worked with deliberate care, treating each junction as if the entire radar network's reliability depended on his precision. By the time his supervisor arrived, Art had treated every vulnerable connection point in the receiver unit. He had also set up his test equipment again, ready to repeat the previous night's humidity exposure experiment. His supervisor, a career military engineer named Frederick Paulson, stopped at Art's workbench with the expression of someone who had already decided whatever they were about to see would be inadequate. Paulson was the kind of officer who had earned his position through a combination of technical competence and rigid adherence to established procedures. He was not a bad engineer, Art had learned, but he was deeply skeptical of unconventional approaches and particularly skeptical of suggestions from civilian contractors who lacked formal military training. When Art explained what he had done and why, Paulson's skepticism hardened into something closer to irritation. "You wrapped the terminals in wax string," Paulson said, his tone making it clear this was a statement of disbelief rather than a question seeking confirmation. Art nodded. "Yes, sir. I believe condensation has been causing the intermittent failures. The wax string creates a moisture barrier that should prevent water from bridging the connections." Paulson picked up the receiver unit and examined Art's work with an expression that suggested he was looking at something vaguely offensive. "This is military equipment, Combs. It's engineered to precise specifications by people with advanced degrees. You think they somehow forgot about humidity? You think wrapping it up like a Christmas present is going to solve a problem that has stumped trained engineers? I think humidity at actual installation sites might be different from what anyone tested in a laboratory," Art said carefully. "And I think simple solutions sometimes work when complicated ones don't." Paulson set the receiver down with enough force to make Art wince. "This is a stupid waste of time. We have actual work to do, not folk remedies from someone who used to fix toasters. Remove all this string nonsense and get back to following proper diagnostic procedures." Art felt his face flush, but he kept his voice level. "Sir, could we at least test it? I've got the humidity exposure set up ready. It'll only take an hour to see if there's any improvement." "I said remove it, Combs. That's an order." Paulson turned and walked toward his office at the far end of the repair bay. Art stood at his workbench, looking at the receiver unit with its careful wrappings of wax string, each one representing his best attempt to solve a problem that was costing the military its coastal surveillance capability during critical night hours. He thought about the submarine contacts being lost because radar screens went dark at the worst possible moments. He thought about merchant ships that might not receive warnings about approaching threats because the systems meant to detect those threats couldn't function reliably. Then he thought about his grandfather, the telephone lineman who had taught him that sometimes the old ways persisted because they worked, not because people were too stubborn to innovate. He looked around the repair bay. Most of the other technicians were focused on their own work. Paulson had disappeared into his office. The receiver unit sat on his bench, officially waiting to have its unauthorized modifications removed. Art made a decision that could have gotten him fired or worse. Instead of unwrapping his string barriers, he filled out a testing completion form, marked the receiver as passing all diagnostics, and sent it back to the supply sergeant for redeployment. Then he pulled up the maintenance database and looked for other receiver units that had been flagged with humidity-related failures. Over the next 3 days, working during hours when Paulson was occupied with other matters, Art treated every one of those units the same way. Wax string carefully wrapped around vulnerable connections, moisture barriers installed on equipment that would soon be sent back to coastal radar stations. He knew he was taking a risk. If the modification caused problems, or if Paulson discovered what he had done before the results could speak for themselves, his civilian contractor position would disappear faster than morning fog under a hot sun. But Art had spent too many years solving real-world problems to ignore what he had learned. Sometimes you had to trust your own observations over other people's theories, even when those other people outranked you. The first report came back 2 weeks later. A radar station on the Maryland coast sent a routine maintenance update noting that a recently serviced receiver unit had operated without any signal dropouts for 12 consecutive nights, including several with humidity levels above 90%. The station's maintenance log noted this as exceptional performance compared to previous equipment reliability. Nobody at the depot paid much attention to one positive report among dozens of routine maintenance updates. The second report arrived 3 days later from a station in Virginia. Their recently serviced receiver had also operated flawlessly through humid conditions that had previously caused regular failures. This report got slightly more attention because the station commander specifically mentioned the improvement in a communication to Fort Hancock's operations officer. By the time the fifth positive report arrived, people were starting to notice a pattern. Radar stations that had received recently serviced receiver units were experiencing dramatic improvements in nighttime reliability. Stations still operating older equipment continued to report intermittent failures during humid conditions. The correlation was too strong to ignore. Paulson called a meeting of the depot's senior technical staff to review the unexpected improvement in field performance. Art wasn't invited to the meeting, being a civilian contractor of relatively low status, but he heard about it afterward from other technicians. According to their accounts, Paulson had presented various theories about why recent maintenance work was proving more effective. Maybe they had finally identified the right tubes to replace. Maybe recent improvements in testing procedures had allowed more thorough diagnostics. Maybe field operators were becoming more skilled at equipment management. It was a supply sergeant named Robert Chen who accidentally revealed the truth. Chen had been tracking equipment serial numbers as part of his normal logistics duties, and he noticed something odd. Every receiver unit currently getting positive performance reports from the field had passed through Art Combs' workstation during a specific 3-day period. The correlation was perfect. 100% of improved units had been handled by Art, and 0% of units still experiencing problems had gone through his bench. Chen mentioned this observation during the meeting, intending it simply as an interesting data point. Paulson apparently went very quiet, and the meeting adjourned shortly afterward. An hour later, Art was called into Paulson's office. The supervisor sat behind his desk with a maintenance folder open in front of him. Art could see his own handwriting on several of the forms inside. Paulson studied him for a long moment before speaking. "I ordered you to remove those string wrappings," Paulson said finally. Art nodded. "Yes, sir, you did. But you didn't remove them. You instead treated every problematic receiver unit in our inventory with the same modification." Yes, sir. Paulson closed the folder. That was insubordination. I could have you removed from this facility and barred from any future military contract work. Art waited. There wasn't much he could say in his defense. He had directly disobeyed an order from a supervisor, and the military took such things seriously even when dealing with civilian contractors. However, Paulson continued, his expression softening slightly, I've just spent the last hour reviewing performance reports from every radar station in our coastal defense network. Units you modified are operating at near perfect reliability. Units you didn't modify continue to fail during humid conditions. Your stupid string solution appears to actually work. Art felt tension. He hadn't fully realized he was carrying drain from his shoulders. The wax creates a moisture barrier, sir. Simple physics. Simple physics that apparently escaped the notice of every engineer who designed and tested this equipment. Paulson stood and walked to his office window, looking out over the repair bay where dozens of technicians continued their work. I owe you an apology, Combs. I was wrong to dismiss your idea without proper testing. I let my assumptions about proper engineering override basic problem-solving common sense. You were following established procedures, sir. Nobody trains supervisors to expect that waxed string might be the solution to sophisticated electronics problems. Paulson turned back to face him. No, they don't. But they do train us to recognize when something works and to implement it across the board. I need you to document your modification procedure in detail. Every step, every material specification, everything another technician would need to replicate your work. Can you do that? Art nodded. Yes, sir. It's not complicated. Good. Because as of right now, every radar receiver unit in this depot's inventory is going to receive your moisture protection treatment before it gets sent to the field. And I'm going to be contacting other depot commanders to recommend they implement the same modification. Over the following weeks, Art found himself in the unexpected position of being the depot's moisture protection expert. He wrote detailed procedure guides, trained other technicians in his method, and consulted on how to extend the same principles to other types of equipment beyond just receivers. The wax string wrapping, initially dismissed as a stupid folk remedy, became standard practice throughout the coastal defense radar network. The modification's effectiveness extended beyond just preventing signal dropouts. Stations reported that equipment treated with the moisture barriers required less frequent maintenance overall. Connections that stayed dry lasted longer, suffered less corrosion, and maintained more consistent electrical characteristics. The simple addition of waxed string wrapping was saving thousands of man-hours in maintenance time and extending the operational life of expensive equipment during a period when replacement components were scarce. Word of the innovation spread beyond just the radar network. Other military systems that relied on sensitive electrical connections in humid environments began adopting similar protection methods. Navy vessels working on their own radar systems contacted Fort Hancock for information about the modification. Army Signal Corps units inquired about applying the technique to field communications equipment. What had started as one civilian electrician's hunch about condensation on exposed terminals evolved into a widely adopted practice that improved the reliability of Allied electronics across multiple services and theaters of operation. Art received a formal commendation from the War Department in October of 1942. The certificate praised his initiative and technical innovation in improving coastal defense capabilities, though it was vague about the specific details of his contribution. He framed it and hung it in the small apartment he shared with Margaret, though he rarely talked about his work in any detail. Like many civilians contributing to the war effort in unglamorous but essential ways, he simply showed up each day and did what needed doing. The irony wasn't lost on him that his most significant contribution to the war effort had come not from following proper procedures or deferring to conventional engineering wisdom, but from trusting his own observations and being willing to try a simple solution that others had dismissed. He thought about all the hours that trained engineers had spent theorizing about magnetron failures and atmospheric interference, complex explanations for a problem that ultimately came down to water droplets bridging exposed connections. Paulson, to his credit, became one of Art's strongest supporters within the military bureaucracy. The supervisor who had once called the string wrapping stupid now regularly cited Art's work as an example of the importance of practical problem-solving over theoretical perfection. He pushed for Art to receive better pay and more authority within the depot's technical hierarchy, arguing that civilian contractors with proven track records deserved recognition equal to that given to military personnel. The coastal defense radar network that Art's modification helped protect never faced its ultimate test. German submarine activity along the American East Coast declined significantly by late 1942 as Allied convoy systems improved and anti-submarine warfare became more effective. But the radar stations continued their vigilant watch throughout the war, their operators confident that their equipment would function reliably regardless of weather conditions. They never knew that their reliability depended in part on wax string wrapped around terminal connections by a former radio repairman who had refused to accept that his simple solution couldn't possibly work. After the war ended, Art returned to civilian life and reopened his repair shop in Camden. He fixed toasters and radios and occasional theater sound systems. The same work he had done before the war pulled him into military service. But now he had a framed commendation on his wall and a story he sometimes told about the time his supposedly stupid idea had become standard practice throughout the Allied electronics networks. He learned years later, through a former depot colleague who had stayed in touch, that the wax string moisture protection method had continued in use well beyond the war's end. The technique showed up in military technical manuals published in the 1950s and 60s, usually without any attribution to its origins. It became one of those standard practices that technicians learned and applied without necessarily knowing where it had come from or who had first figured it out. Margaret used to joke that her husband had saved America with a ball of string and a can of wax. Art would smile and point out that plenty of other people had contributed far more dramatic and dangerous efforts to winning the war. But privately, in moments of reflection, he allowed himself some satisfaction in knowing that he had been right when more educated and credentialed people had been wrong. He had trusted his own observations, taken a risk, and solved a problem that had stumped engineers and threatened a critical defense system. The story of how Art Combs' modification spread throughout Allied electronics serves as a reminder that innovation doesn't always come from expected sources or follow conventional paths. Sometimes the person who fixes the problem is the one willing to try the simple solution that everyone else has dismissed. Sometimes the stupid idea turns out to be exactly right. In the decades since the Second World War, military and civilian electronics have evolved in ways that would seem miraculous to the technicians who worked on coastal defense radar in 1942. Modern systems use hermetically sealed connectors, conformal coatings, and sophisticated materials specifically engineered to resist moisture intrusion. The problems Art faced with condensation on exposed terminals have been solved through better design, rather than improvised field modifications. But the fundamental principle he demonstrated remains relevant. When equipment fails in the real world, the solution might not require reimagining the entire system or waiting for advanced materials to become available. Sometimes you just need someone willing to look at the problem with fresh eyes, trust their own observations, and try the simple fix that works. Someone willing to risk being called stupid in order to find out if they might actually be right. Art Combs died in 1976, having lived a quiet life as a small business owner and occasional consultant to local companies with electrical problems. His obituary in the Camden newspaper mentioned his wartime service but didn't detail his specific contributions. The commendation certificate still hung in what had been his home office, eventually passed down to his children and then his grandchildren, a tangible reminder of the time their relative had improved America's coastal defenses with wax string. The radar stations he helped keep operational were decommissioned long ago, their functions assumed by more advanced systems, or rendered obsolete by changes in military strategy and technology. But during the critical years when German submarines threatened American shipping and coastal cities lived under the shadow of potential attack, those stations provided essential early warning capabilities. The operators who watched their screens through long night shifts never knew about the condensation problem or its solution. They just knew their equipment worked when they needed it to work, and in military operations, reliability often matters more than sophistication. There's a small display in the Fort Hancock Museum now, located in one of the old coastal defense buildings that has been preserved as a historic site. Among exhibits about the radar stations and the soldiers who served there, there's a section on civilian contributions to the war effort. In a glass case sits a piece of wax string wrapped around a terminal block, accompanied by a placard explaining how a simple modification by a civilian electrician named Arthur Combs improved the reliability of the entire coastal radar network. Most visitors probably walk past it without much notice, their attention drawn to more dramatic artifacts like uniforms and weapons. But occasionally someone stops, reads the placard, and considers the story behind that piece of string. They think about the courage it took to ignore a direct order because you believed you were right. They think about the humility required to listen to someone outside your professional sphere when they offer a solution that seems too simple to work. They think about all the complex problems in the world that might actually have simple answers, if only we're willing to look for them, without prejudice about where good ideas are supposed to come from. Art Combs never set out to be remembered as an innovator, or to have his work displayed in museums. He just wanted to fix a problem he understood better than the people dismissing his solution. He wanted radar operators to have reliable equipment, because he knew lives depended on it. He wanted to contribute something meaningful to a war effort that needed every advantage it could get, no matter how humble the source. In the end, that's exactly what he did. Not with heroic sacrifice or brilliant theoretical insight, but with careful observation, practical knowledge, and the willingness to be called stupid while proving himself right. His legacy lives on not just in the display case at Fort Hancock, but in the principle he embodied, that sometimes the most important innovations come from the people actually doing the work, the ones willing to trust what they see, even when everyone else insists they must be wrong. The stupid wire fix that saved America's radar network wasn't stupid at all. It was simply elegant, practical, and perfectly suited to solving the exact problem at hand, just like the man who invented it.